Hi, this is Mr. Max. So today I am doing algebraic equations and inequalities as well as sequences. So this work is suitable for the grade 9 learners, grade 8 learners can also have a crack at it, and so can learners in general who struggle with equations, algebraic equations and inequalities as well as sequences. Right? So, in the syllabus for the junior secondary phase, this is the bullet points that the learners need to be able to master when they are dealing with these specific topics. So, we're going to look at them by doing a few examples or solving some questions that are fitting to what the syllabus is requiring. So I'm going to go right to it. I'm going to do a few questions, revision questions. So the first deals with solving equations. So this is a linear equation where you have the unknown on one side of the equal sign. So the objective is to make that y to be on its own to make it the subject of the formula. So we're going to get rid whatever there are. So you need to look at the left-hand side. I've got two terms. So that minus 7 needs to disappear. So it doesn't just go over the equal sign. All right. So we have to add the opposite operation of subtraction is addition. So when you add that positive 7 to negative 7, obviously it becomes 0. But what you do on the left, you should also do on the right. So that brings you to 5y equals to 15. In fact, from here on, you can start solving this specific question because it asks you 5 multiplied by what gives you 15. So the opposite of multiplication is division. So you should know that 5 times 3 gives you 15. Now, the second one here, you have got an x on both sides of the equal sign. So this is called having the unknown variable on both sides. So you then collect like terms. That means all the terms containing the x on one side, preferably on the left, and all the numbers on one side, because you cannot add and subtract unlike terms. So you now only subtract the coefficient. 10 minus 5 gives you 5x, okay? All right, I always say this is the same thing as having 10 sweets, take away 5 sweets, you're obviously left with 5 sweets. So that's basically it. And on the other side, 8 minus 2, well, 8 minus 2 gives you 6. All right, so you just have to make sure of that. And then you divide by 5 in order for you to get x to be on its own. All right, and x is going to be then 6 divided by 5, that improper fraction that you can then write as a mixed number. Right, so the next one here is 4 over p equals to 5. The p is a denominator, it's a bit tricky. So I would suggest that you put this 5 over 1. Okay, and then you can do cross multiplication, which is much easier, and then perhaps have the variable on the left side. 4 times 5, 5 times p is 5p, and 4 times 1 is 4. And now you get rid of that 5 there by dividing throughout by 5. And then you should get p 2 equal to 4 over 5, or 0.8, okay? So let's look at a further equations here. So we have got the x plus 2 in brackets here, and then we have a 3 here. So this is one term. So in order for us to get the x to be alone, we need to expand. We need to remove these brackets. We need to multiply out. All right? And when you do multiply out, 3 times x gives you 3x, and 3 times 2, that gives you 6. All right, so now it is like our previous examples we did. So now we collect the like terms, all the x's on one side, and you can take the number to the right. Okay, and now if you have 2x is equal to negative 6, you divide both sides by 2 in order for you to get x equals to negative 3. So let me bring in another one. Still you have the unknown on both sides, but here there's little something here. This x minus 8 is being doubled, so you have to remove the bracket like what we did in the previous question. So I'm going to simplify that side by multiplying that 2 with the x gives you 2x, and 2 times the negative 8 gives you negative 16. All right, so then I clean this up a bit. So 6 minus 16 gives me the negative 10 that you see here. All right, so I will also say, so avoid just starting to move terms over the equal sign. Simplify what you can, and then collect like terms, and then you can start with your correct manipulation. So now you have to divide negative 6 by 3, and you're going to get the answer that x is equal to negative 2. Let me bring in 2 more. So here you have got 2 terms, so we have to isolate the a over 4. So we'll get rid of that 8 by adding 8 to both sides. So when you add 8, on the other side you're going to get 6. And again, as I said, put a 1 and 6 over 1, then do cross multiplication. Okay, and when you do cross multiplication, well, you're going to get a equals to 24. Right, here you have got the quantity 5y plus 1 all over 3 equals to 7. You can put that 7 over 1 if you want to. All right, and don't do cross multiplication. It's also another method that you can do it, but I have done something. I got rid of this 3. The opposite of division is multiplication. So I multiplied both sides by 3. So if I multiply on the left, the 3's will sort of cancel out. All right, leaving me 5y plus 1 equals to 21. Again, as I said, if you cross multiply, you get 3 times 7. That 21 is coming right back here as well. Then you subtract 1. Obviously, you're going to get 5y equals to 20. Now, you get 5 times what gives you 20. Divide by 5. Y is equal to 4. Right, so the next question is a little word problem that I have here. It says Tim is thinking of a number, and if he multiplies the number by 2 and adds 14 to the result, the answer is the same as if he multiplies the number by 4 and subtract 8 from the result. Right, so this is the first part. He multiplies 2 and adds 14. But then the sentence continues and says the answer is the same, so equal to, as he multiplies the number by 4, because I say let that number be x, and then subtract 8 from the result of multiplication by 4. So now you have got that particular part where you collect like terms. Now take note, I took the 2x to the right. You could have done the other way around. You could have taken the 4x to the left. I just try to avoid working with negative values. Okay, so collecting like terms gives you 4x minus 2x is 2x, and 14 plus 8 is 22. When you solve for x by dividing throughout by 2, you get that x is equal to 11. Another word problem says Amy is n years old. So let's write that in terms of n. We don't know how old Amy is. She could be 10, she could be 9, she could be 5. So we use n. Her brother Bobby is 9 years older. So when someone is 9 years older, you add 9 to the age of the other person. So we don't know how old Amy is, but whatever Amy's age plus 9, that gives you Bobby's age. The mother is 3 times as old as Amy, so again, Amy's age times 3, that's how you write it. The father is twice as old as Bobby, so Bobby we know is n plus 9, so you then multiply n plus 9 to whole n plus 9 times 2. All right, so you can actually also multiply that 2 over to get to n plus 18. Okay. So they are saying if you add all of these, you should get 129. That is the sum of the ages of the 4 members of the family. So they're saying write it on the equation. So it's very straightforward and easy. So you take all of that stuff and you let it equal to 139. So now you try to collect like terms. When you collect like terms, eventually you should end up with 7n plus 27 is equal to 139. That is the equation that we're looking for. Okay, it's sort of simplest or simplified equation. All right, now you solve that equation. That means you're going to subtract 27. When you do that, you get 112, and then you're going to divide throughout by 7 so that n is equal to 16. Right, so now there's a second part here. It says find the mother's age when Bobby was born. So this can be a bit tricky because you can struggle with this. When Bobby was born, he was 0 years old. Okay, all right, maybe some days, some hours, so he was not yet complete year. So something must be subtracted. So what I do is, since I know what n is, which is effectively the age of Amy, I then write everyone's age down. So Bobby is going to be 25 years old. The mother is 3 times Amy's age. It's going to be 48 years old. And the father is going to be 50 years old. So now I know the mother's age. I know Bobby's age. So I just then take the mother's age, subtract Bobby's age from the mother's age. So the mother was 23 years old when she had Bobby. Question 4, in the previous video, I have spoken about consecutive numbers, numbers that follow each other, like 6, 7, and 8. And when you write the first number or the numbers in terms of the first, so using the first, like 6, and the next one obviously to get 76 plus 1, to get 86 plus 2, to get 96 plus 3. So when we use a letter, let's suppose we use a letter like x. X is going to be the first one, next one will be x plus 1, x plus 2, x plus 3, and so on. So therefore, we let that equal to 22. So we create an equation, all right? We'll add all the stuff and that is equal to 22, and the equation is 4x plus 6 is equal to 26. The 4x comes from x plus x plus x, and this 6 here is 3 plus 2 plus 1. Now, you solve this equation, subtracting 6 from both sides, it gives you 4x is equal to 16. Then you divide by 4 to get x is equal to 4. So, the first number is 4, the second number is 5, the next one is 6, and the last one is 7. These are the 4 consecutive numbers. Right, now we have another question. It says Peter and Paul. So Peter has $20 and Paul has 212, and then they are given each some money. We don't know how much that is, so we're going to add that to what they have already. Okay, so we're going to add an x to Peter, it's 20, and an x to Paul's 212. Now they're saying that Paul has 5 times as much as Peter. So that means if you want to equate them, all right, if you want to say, okay, whatever Peter has, to get that, you take Paul's, or whatever Paul have, to get that, you say Peter's money times 5 should equal to what Paul has. Then multiply that 5 over, you get 100 plus 5x. Collect like terms, you get 4x is equal to 112, right? Divide by 4, you now know x is equal to 28. Now let me just quickly test that theory to see if I do get 5. Yes, so when I have x to be 28, then Peter has 48, and Paul has that 28, he has 240. To check dividing 240 by 48, 5, so Paul has 5 times as much money as Peter. Question 6, 2 number lines are drawn. So this question deals with inequalities, right? So we're looking for any number that represents that is less than -1. So numbers that are less than -1 are numbers that are on the left side of the number here. So that includes numbers like -2, -3, -4, and up to infinity, but not -1. So if there is no or equal sign here, then you have an opening here at the tail, okay? So you don't shade that part. Like for example, this one here, you're supposed to represent numbers that are greater than or equal to 2. So 2 is included. So the numbers could be 2, 3, 4, 5, up to infinity. Right, now I'm going to give you another one here. So this one here, you have got to write down the inequality sign here. So this end here is shaded, -1, and 3 is open. So 3 is not part of the solution, it's not included. So the inequality reads that x is a number that is between -1 and 3, but 3 is not included. So x is greater than or equal to -1, or x is less than 3. And all these numbers, -1, 0, 1, 2, if it's integers we are talking about, positive whole numbers, negative whole numbers, and 0, then we are referring only to the numbers -1, 0, 1, and 2, but not 3. Right, question 7, write down all the integer values, integers, positive whole numbers, negative whole numbers, including 0, that will make this particular inequality true. Well, you can make a number line, but you should know it should be -2, -1, 0, 1, 2, and 3. But 4 is not included because that inequality sign does not have a or equal to there. Now, when you solve inequality, you have to be a bit careful. You solve them the same way you would solve equations, but there is a little catch involved when you need to swap the inequality sign around, especially when you multiply or divide by negative. So look at the coefficient of your variable. So in this case, I have a -5. But first, let's manipulate. Get that 7 to the right. That gives you 10. And now you see I must divide by -5. And because I'm dividing by -5, the inequality sign ought to be swapped. Otherwise, it's not going to be true. The statement won't be true. You have to reverse that sign. So I'm only doing my reversal here, okay? and I divide by -5, then x should be a number less than or equal to -2. Right, so a room is A meters long, B meters wide, so we don't know what is the length, we don't know what is the width, so we substitute them with A and B. They say write down a formula for the perimeter. Perimeter is the total distance, so A plus B plus B, so that's 2A plus 2B, P equals 2. Right, so the next question they probably tell you P is this, B is that, and find A. So when A or B is 2 and P is 20, what is A? A is equal to 8. So you do the substitution into the formula and then you solve the formula. Right, this particular part of the video I am doing triangular numbers. Now I've decided to take triangular numbers because it is one of the sequences that a lot of students are struggling with. So I've tried to break it down in a very simpler way. Okay, so triangular numbers can be represented in a form of a triangle, so I decided to use right angle triangles. Okay, so just to see what the formula will be. So this is the first dot. This one has got 2 dots. So the next triangular number I can create has got 3 dots. Can you see that the triangle is coming? The next one, obviously, so this is the term. The third term has got 6 dots. And the fourth term will have 10 dots if you count them. So it has a sequence. There is a sequence that is being created here. The sequence is 1, 3, 6, 10, and so on. These numbers, they don't have a common difference. They are called triangular numbers. So the objective is, if I was to ask you to find the 13th number in the sequence, how are you going to do that? All right, so there is an easy way that one can do it. So I will definitely show you. So what I did is I am now adding another dot on top. Okay, so on this side I have got 2 dots now, and I'm going to add the other 3 dots on top, and you can see that there is a rectangle that is being formed. If I add other dots there, can you see now I've got 4 dots? So now I've got, if you count all the dots, it's 12. And if I do the same here, take this stuff and just flip it over. All right, so I've got 5 by 4. So these dots here are 20, this one's here 12, this one's here 6, this one's here at 2. Remember our formula to find our sequence was 1, 3, 6, and 10. But if I double the stuff now and I did what I did there, so now I realize that it's 2, 6, 12, and 20. So I want to find the black ones. So I must then every time divide these answers by 2. Alright, so what is the simplest way of then representing them? So in simple way of representing them, in order for us to come up with some sort of workable solution, is look at the dots and multiply. It was a rectangle, okay? And a rectangle 1 times 2 gives you obviously 2, and then you divide by 2, so I get 1 dot for the black one. Here it's 3 times 2, which is 6, divided by 2, that gives me 3 black dots. 3 by 4 is 12, half of 12 is 6, 5 times 4 is 20, half of 20 is 10. So the rule is, you take the term, and then in bracket, 1 more than that term, and you divide it by 2, alright? So the 13th one can simply be found by saying 13 times 14, but remember 14 is written now as 13 plus 1. That's half of 182, which is 91. So you don't have to study the formula by heart, but this is very helpful, and if you can remember it, you should be able to find the next one or even the 20th one, depending on what the question asks of you. Right, so I'm going to do a few questions then on sequences. So you get the sequence 4n plus 5. So they are asking you here to find the first 3 terms of the sequence. So it's very easy. Term 1, you just substitute for n and the position of the term by 1. So the first term will be 9. The second term will be 13. And the third term will be 17. So my sequence is going to be 9, 13, and 17. And the sequence is also going up. It's increasing every time by 4. That 4 there that you see in front of the n is called the common difference. Right, so now they're asking you which term is equal to 105. So when you continue this pattern, what term, what position will be 105. So use the formula. Okay, so the formula for n plus 5, then you say let it equal to 105 and you solve because you want to find n, which term is equal to 105. You subtract 5 from both sides, you divide by 4, you get 4 equal to, or n equals to 25. So therefore the 25th term is equal to 105. That is how this particular question is supposed to be solved. So I've got one more here. Question 2. You are supposed to determine the nth term, the rule of the following sequence. So I have a sequence here, 5, 8, 11, and 14. So the first thing you do is you work out what we call the common difference. So you take the term 2 minus term 1, or term 3 minus term 2, or term 4 minus term, you subtract them in that order. And obviously, as you can see that this sequence here is increasing, I expect my common difference, which we represent by this small letter d, it is a positive number, okay, and it's positive 3. So secondly, I'm going to bring in a table. Now the stuff in red here is the position. The first term is 5, the second term is 8, the third term is 11, the fourth term is 14. What is the nth term? What rule, what relationship exists there? What rule can we just find by saying now what is going to be the 100th term without having to do these things, on a manual way? Okay, so what I like to do is I take my my term. So I know the common difference of 3. So if I say 3 times 1, all right, I know 3 times 1 is 3, but if I need to add something to get to that 5. I know that 3 times 2 is 6, but I need to add something to get 8. And I know also that 3 times 3 is 9. I need to add something to get to 11. And I know that 3 times 4 is 12. I need to add something to get to 14. So in all the cases, when you solve this, you're going to realize you end up with, yes, x equals to 2. Right, so my rule, the thing that combine is 3n, n is the position, plus 2. That is how you find the rule. It's trial and error, and you should be able to identify it fairly easily. Then the sequence I brought it in because you can see the sequence is decreasing. That tells me that the common difference must be a negative number. So when I do the subtraction of the successive terms, term 2 minus term 1, I know I get negative 2. I just did another one just to see if the sequence has a common difference. When I bring them in my table and I do the stuff on the side, I say negative 2, which is my common difference, times the first one. I need to add something there to get a 7. Okay, and the same, negative 2 times 2 plus what gives me 5. Negative 2 times 3 plus what gives me 3. So in order for me to find that plus what I'm referring to, you will see if you solve for x, and every time you're going to get x equals to 9. So my formula is negative 2n plus 9, or 9 minus 2n. This is the formula that is going to allow me to answer a question like B Roman 2 here. Which term is equal to negative 63? So you use the formula. You use the formula and you let it equal to negative 63. You want to find that n, that position. And when you do that, you realize that n is equal to 36. Therefore, the 36th term is equal to minus 63. I hope you have taken it all in. You can rewind the video. You can check and make sure that you understand things. Pause it at times when you don't get something.